again. All right. So, what we're going to learn today is what is called implicit differentiation. So, a couple classes ago, now it's after turkey break, so it's actually been a couple weeks since we did this, but when we were doing our optimization problems and we were finding the maximum area when we were fencing in a field, or we were minimizing the fencing, all that good stuff, we ended up with a function with two variables, the length x and the length y. We were able to do substitution to get rid of one of those variables, so we were only taking the derivative with one variable. Sometimes that's not going to be possible. We're not going to be able to get rid of or substitute in for that second variable. So we're going to take the derivative with multiple variables. Okay? We've actually been doing this already this year when we've been doing our chain rule. When we've been using that du or our dy sometimes, that has been implicit differentiation. So let's look at an example. Okay? If we had x squared plus y squared equals 25. Okay? This function represents, well, this isn't really a function because it doesn't pass that vertical line test. But this equation here represents a circle that's centered on the origin with a radius of 5. So if we look at that graphically, quick sketch, it looks something like this. Okay? So here is why the implicit differentiation comes into play and how it's actually kind of cool. If I want to find the slope, so what is the slope at x equals 2? All right? Let's say 1, 2, 3, 4. All right. 2 is here. I want the slope. But the problem is I have this point at x equals 2, and I have this point at x equals 2. So there's two different slopes. Is my slope going to be this negative slope up here, or is it this positive slope down here? The slope doesn't just depend on our x value anymore. It depends which y value we're choosing. So we take the derivative using implicit differentiation, and our derivative is going to include x and y. So we would actually be plugging in the point instead of the x value. So let's take a look. If we're going to take the derivative of x squared plus y squared equals 25. If you remember the notation, d dx. X squared plus y squared equals 25. We're going to take the derivative of this. What we can do is we can treat this like our multiplication, and we're going to distribute that derivative in. We're going to take the derivative piece by piece. So this becomes the derivative with respect to x, the d dx of x squared, plus the d dx of y squared. Take the derivative with respect to x equals d dx of 25. All right. So we have to take into account what variable we're taking the derivative of. So here, I need to take the derivative of x squared. What's the derivative of x squared? Just kidding, I can't hear you. 2x. We took the derivative of an x variable, so this becomes dx dx. Right? The derivative of x with respect to x. Plus the derivative of y squared, so we're going to get 2y dy dx. We took the derivative of y with respect to x, dy dx, equals the derivative of 25. 25 is a constant, so that derivative is 0. what's dx divided by dx? Okay, we know that that's just 1, so we can reduce that out of our equation, and what we're looking at right now is 2x plus 2y dy dx equaling 0. So, the calculus part is over. We took the derivative, we kept it in terms of our variables, and now our final goal, our step, algebra. We want to know what the dy dx equals, the change in y over the change in x, the slope. So I want to know what dy dx equals. So we're going to isolate it, get it by itself. So I'm going to start by subtracting my 2x over. Okay, so now we have 2y dy dx equals negative 2x. And then I'm going to divide by my 2y. And this now tells me, I'm going to write it up here, that my dy dx equals negative 2x over 2y, which reduces to negative x over y. So we see that our derivative is now in terms of x and y, so I can plug in this point, the x value and the y value, and it's going to give me that slope. Does that make sense? A little bit? Yeah? Okay, let's work through another example, see how that feels. All right. Should play some theme music or some Jeopardy music while I'm erasing. Good times. If I'm going fast, which I probably am because I'm just in a room by myself, you can hit pause, rewind, view things, all the stuff you can do with videos normally. All right, so we're going to look at an eclipse. It's not an eclipse. That's like the sun and the moon hanging out. We're going to look at an ellipse. That's math stuff. All right, we're going to do x squared minus x times y plus y squared equals 7. And we're going to look at the point 1, negative 1, 2. Okay, this is the equation of an ellipse. If you took 1050, 1060 or pre-calculus, you've probably learned about that. My Math 3 Honors kids, we have never seen that, so cool. It's just a graph. Looks something roughly like this, okay? And we're going to try to find the slope at negative 1, 2. What's the slope of that tangent line there? So to be able to do that, we have variables x and y, so we're going to take the derivative with respect to x. So what's the derivative of x squared? This is 2x, and that dx is always going to reduce out, so I'm just going to take the derivative with respect to x, 2x. Cool. Now I have a negative x times y. X times y means what rule do I have to use? Yes, the product rule. Are you guys as uncomfortable as I am with all my teaching jokes when you're not here? Cool. Sweet. All right. We're going to do the product rule. We are subtracting. I'm going to put this in parentheses because we're subtracting this whole derivative piece. So I'm going to do my left, d right. The derivative of y is 1 dy dx. We took the derivative of a y, so it needs the dy dx. So left, d right, plus right, which is y, d left. What's the derivative of x? 1. Left, d right plus right d left. Sweet. Plus, we have a second y. So when we take the derivative of our y squared, this is going to become 2y dy dx. Derivative of y squared is 2y dy dx equals the derivative of 7, which is 0. Calculus, done. Algebra, here we go. So, what I'm going to do, I'm going to first take care of this negative. So I'm going to distribute in my negative. 2x minus x dy dx plus, nope, I'm distributing my negative. So minus y plus 2y dy dx. So our goal is to isolate dy dx, but we have two of them. So to isolate my dy dx, I'm going to move my 2x and my negative y to the other side of the equal sign. Okay, so I'm going to subtract my 2x and I'm going to add my y. So this becomes negative x dy dx plus 2y dy dx equals y minus 2x. Okay, all my dy dx's are now on the left side of the equal sign, and all of my other variables with no dy dx's are on the right. Okay, these two terms, negative x dy dx and 2y dy dx, what do they have in common? They both have the dy dx, so what I'm going to do is I'm going to factor out that dy dx. Alright, so dy dx equals, not equals, I'm factoring it out, so dy dx times negative x plus 2y. Yeah? So these two terms had a dy dx in common, so I'm going to factor that out front. So now I only have the one dy dx. How can I get it by itself? How can I isolate the dy dx? My final step, I am going to divide by my negative x plus 2y. So from here, we're going to get our solution. Our isolated dy dx equals y minus 2x divided by negative x plus 2y. Order isn't important. This could be negative 2x plus y. Down here you could have 2y minus x. We're going to get the same slope, so don't get too stressed if your isolation looks a little bit different or your order is a little bit different. If this is my derivative, I want to know the slope at the point negative 1, 2. So my final step, I'm going to plug in x and y to find that slope. So I'm going to plug in 2 for y, negative 1 for x, this is going to give me 2 plus 2 over 1 plus 4. And I'm going to get 4/5 as my slope. Okay, so remember, this point right here, we'll start at this point. That's when we were done with the calculus. We took the derivative, we put on the dy dx when we took the derivative of y, and then from there, it was just the algebra. Okay, the final step, find the slope at this point by plugging in the negative 1 for x and the 2 for y. If you look in the book, okay, there are more examples. On page 164, it describes the process for implicit differentiation. Okay, it says, I'll read it to you. Differentiate both sides of the equations with respect to x, which was this line. We took the derivative of everything. Collect the terms with the dy dx, meaning group these two together, the dy dx's, factor out the dy dx, and solve for it, meaning get it by itself. That's all it is. Take the derivative, isolate your dy dx. Okay, so last thing we're going to talk about real quick as quick as I can. Our previous lesson, concavity, we had to use the second derivative. If we were to move further than that, we'd be looking at third derivative, fourth derivative, whatever. How do we do higher order derivatives with the implicit differentiation? We're going to take a look at that real quick. All right. More theme music. You guys want to sing it for me while I erase? No? All right. Cool story. Can fast forward these parts. Maybe I'll cut them out. Who knows? No, I'm too lazy for that. It's going to stay. All right. So we're going to find the second derivative. So find f double prime of f of x equaling, we're going to do 2x cubed minus 3y squared equaling 8. 2x cubed minus 3y squared equaling 8. Second derivative. All that means, take the derivative, and then take the derivative of the derivative. So, we're going to take the derivative of f. So, hey guys, we're not going to call it f of x. That's silly. Whoops. Obviously, it's not a function. It's the equation 2x cubed minus 3y squared. So, notation-wise, this would actually say find d squared y over dx squared of this guy. Whoops, it's all good. All right, second derivative. The first derivative, I'm going to end up with 6x squared minus 6y dy dx equaling 0. Here's the derivative of 2x cubed. Here's the derivative of 3y squared. All right? I'm going to isolate my dy dx. So I'm going to subtract the 6x squared over. And then I'm going to divide by my negative 6y. So here, my dy dx equals negative x squared over y. You can put the negative in the numerator, the denominator, out front. Means the same thing with fractions. I'll either put it out front or on the numerator, never the denominator. That's not my thing. All right, first derivative, done. Now I want the second derivative. When we take the second derivative, what rule are we going to be using? We have x squared over y, over or divide. We're looking at quotient rule. So to take the second